In example 7, we're changing things up just a little bit from our past examples, and this time we have a circle that has a radius of 5 feet, and we want to find the length of the arc that's intercepted by a central angle of 0.7 radians. If you want to, it's a nice idea with these problems to just draw a little diagram. We'll see how perfectly I can draw this circle here. And so you'll notice that the radius here is 5 feet. We can fill that in. And then the arc is intercepted by a central angle of 0.7 radians. Remember that 1 radian is about 57 degrees. And if we have 0.7 of that, I'm going to try to draw that as accurately as possible. Also notice that we have less than 1 radian, and 1 radian is just the angle measure that produces an arc length of 1 radius. So what we're expecting for this value of s over here is something that is smaller than 1 radius, about 0.7 of that radius. I can write this in here. This is 0.7. I'll put RAD for you, 0.7 radians. Hopefully you guys can see that it's perhaps a little bit small. But just draw whatever diagram you like. Try to get it as close as you can, even though it's not going to be exact. Then all you need to do is utilize a formula, and this time I'd like to utilize the one in radians. S is equal to r times theta, or theta times r, either way. And when you're utilizing this formula, you need to make sure that theta is in radians. It is. So all we need to do to find the length of the arc is to take the radius, which is 5 feet, and we're going to multiply that by 0.7. You can include the feet here in the middle of your steps, or if you choose to leave it off, just understand what your unit is and that you're finding the length of an arc, which is a distance, so it's just going to be in feet, not feet squared. So s in this case will be 5 times 0.7, which is 3.5, and we want to include our units here. This is the exact value. This doesn't say to round to anything. So 3.5 feet is a good, appropriate answer.